In Part 4 of Lecture 1, we will discuss parallel and real-time systems. When John von Neumann first proposed what is now known as the von Neumann architecture, he wrote of a computer with one processor handling one instruction at a time. But increasingly, computers having multiple processors or multiple cores are becoming more popular. Systems like these typically have processors in close communication, sharing the computer's bus, memory, clock, and peripheral devices. These are called tightly coupled systems. The question is, why build such multiprocessor systems? There are a variety of different reasons depending on the particular system. For one thing, it will generally increase throughput. Multiple processors can do much more work than one processor can. Additionally, their processors can share peripheral devices, cabinets, and power supplies, giving it an advantage over having several computers, each with one processor. An additional advantage that they have is increased reliability. This becomes a matter of what can be called graceful degradability, where the service provided can be proportional to the surviving hardware. In other words, we may see a diminishing of service, but we won't see one component taking a device out of use. Also, devices like these can be what are known as fault tolerant. These are systems designed for graceful degradability. When talking about multiprocessing, it can be either symmetric or asymmetric. Symmetric multiprocessing assumes that each processor is running the same copy of the same operating system. Further, it is assumed that any one of these processors can run any of the same tasks that any other processor is running. Any one of them can be replaced by any of the others. Asymmetric multiprocessing is a different story, where each processor has a specialized task, and you may not have a situation where a given processor can be replaced by another one within the same system. Before the advent of multi-core processors, one trend that became fairly popular was processors that did not share memory or a clock. These were known as loosely coupled systems or distributed systems, and they are still around. Why are distributed systems popular? There are a variety of reasons. One is resource sharing, that multiple systems can end up sharing files, share peripheral devices, and other resources as well. In addition to this, you can have speed up of the computational work by load sharing. If you have a large problem, such as trying to figure out the weather patterns for the next 3 weeks, the fact that the work can be shared by many machines speeds up all the computation that needs to be done. Distributed systems are also reliable. If any of the machines that make up the system overall go out of service, the rest of the service continues operating. Additionally, they provide for communication between the various computers making up the system. Real-time systems are computer systems that interface in the real world and have rigid real-world time restrictions for completing many of the tasks. To give you an example of this, it would not make sense for an elevator control system to recognize that we are now passing the second floor if the second floor is long gone and we're somewhere past the fourth floor. Other examples include automobile fuel injection systems, medical imaging systems, and robots. Real-time systems can be categorized as hard real-time or soft real-time. Hard real-time systems require that all critical tasks must be completed on time, meeting whatever deadlines are set for them. In soft real-time systems, critical real-time tasks get priority over other tasks and still need to be bounded. They cannot wait indefinitely, but there is greater flexibility in terms of the deadlines that they need to meet.